Okay, so let's unpack this. We are going to dive into that black box, the hidden world of server-side programming.
Hmm.
We're moving way beyond, the pretty stuff you see in a browser. Our mission here is pretty simple, to help you quickly grasp the architecture that makes it all work when you click a button.
And what's fascinating, I think, is the core distinction here. This is the code that runs securely on the server.
Mm.
It's powerful.
Right.
The browser just handles the presentation, but the server is the brains. It manages requests, it executes all that essential business logic, and critically, it handles all communication with your data.
And the backbone of that whole conversation is the request-response cycle.
Exactly.
It feels instant, like it happens in milliseconds, but it's this profound back and forth. It starts the second you send a request, say submitting a sign-up form.
Right.
That request travels to the server, which then processes the logic. It verifies your inputs, maybe talks to the database, and then it generates a response and sends it all back to your browser.
You can almost think of the server as like a highly organized librarian.
Okay.
You hand them a request slip, they go into the stacks, that's the database, fetch the right book, and bring you back only the information you asked for.
Yeah.
But that processing step is, wow, it's intense.
And it relies on a whole toolkit of languages, right? That choice seems to have huge trade-offs.
I'll check.
It's not just picking a language, it's more like picking a philosophy. Our sources point to choices like JavaScript on Node.js,
Yeah.
which is incredibly efficient for speed and scalability because it handles things asynchronously. It doesn't wait for one job to finish before starting another.
And then you contrast that with something like Java, often using Spring Boot. While Node gives you that agility, Java provides the industrial scaffolding. It's built for sheer, robust, enterprise-level reliability.
I mean, Python.
Python with Django is loved for its clean, readable syntax. That usually means faster development. So you see you're constantly trading like deployment speed for reliability, or the other way around.
That makes perfect sense. But that whole processing step, it couldn't handle any of the business logic at all if the server wasn't constantly talking to its real partner, the database.
Absolutely. The server is the bridge.
It's authenticating users, storing sensitive info, fetching records, and we see two major philosophies here. The very structured SQL systems, like PostgreSQL,
Where you need a defined schema.
versus the flexible NoSQL options like MongoDB, which are great for rapid changes and huge amounts of unstructured data.
And to connect this to the bigger picture, the server needs a standard way to manage all that data flow. And that's through APIs, application programming interfaces.
Yeah, okay.
They're so significant because they allow communication not just between the front end and the back end, but they also let mobile apps and, third-party integrations use the exact same server resources.
So an API is sort of like the standardized menu and the waiter for the kitchen.
That's a perfect analogy.
The front end tells the API, hey, I need this user's profile picture. The server processes it, gets it from the database, and just returns this clean little data packet, usually JSON.
Precisely. It keeps everything modular. And because the server holds the keys to all that data, security logic must stay there.
It has to.
This code is absolutely non-negotiable for authentication and authorization, checking who you are and what you're allowed to do, and for robust data validation.
Right.
It's the critical layer that prevents malicious requests, like a SQL injection attack where someone tries to sneak bad commands into your database.
And that's really the why we care, isn't it? This code is hidden, but it governs integrity. This is the architecture that powers pretty much every single digital interaction you have.
It's the engine. It's behind your login process, the complex inventory checks when you're in an e-commerce checkout, how your social media posts get validated and saved instantly.
Fantastic. So you should now have a really solid foundation for understanding this entire back-end architecture that underpins the whole dynamic web.
So since that server-side code is responsible for both scaling and security, consider this for a second. We touch on SQL versus NoSQL databases. How does that initial architectural choice, whether you prioritize strict data integrity with SQL or massive scale and flexibility with NoSQL, how does that fundamentally change a web app's ability to manage rapid growth a year or two down the line? That's the next layer of exploration just waiting for you.